Welcome back to codingcat.dev, where we give you cats the freshest dose of dev snacks. Here is Alex Patterson and Brittany Postma. This episode brought to you by Storyblok. Build anything and publish everywhere. Hello, Purrfect Picks. Welcome back. Today you might notice Brittany is out, so she's taking a little vacation, a little time away, and you just are stuck with me. So sorry about that, peeps. We do have Oren on. We're going to talk all about RavenDB today. So welcome, Oren.
Thank you for having me. Great to be here.
Thanks for coming. Appreciate it. So basically, before we get too far into the product, I want to hear more about your background and kind of how you ended up kind of starting this amazing product.
My day job is building RavenDB, which is, as you can guess from the name, a database product. And I got here by accident, basically.
It's always a fun accident.
Yeah, it's about 20 years ago, I was looking for an open source project to do. And I started using a project called Hibernate, which is an object relational mapper that helps you work with relational databases. And I got pretty deep into the project. I was heavily involved, became a committer for a while. And something really interesting happened. I started getting some consulting jobs around that. And eventually it morphed into being that guy that comes and saves the application. My application is slow. We cannot, the database can't handle the load. How do we fix that? And I got used to coming to people and fixing horrible database mistakes. And take into account that the thing that I kept doing was exactly the same. At one point, I sent a report for customer A to customer B. And I didn't catch that. When did I catch that? When they told me that, oh, you're very insightful in your blah 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 blah, but we don't understand where you found the policies table or something, because the report I sent them was from a customer who deal with insurance, and they were current company or something like that. Like, I said to the whole team, that's not insightful. That's really bad. It was a Word document, nothing really that interesting though. But it turns out that the report that I gave was so hitting so many common pain points that it was usable across very different applications, very different industries. And what ended up happening was that I got really, really tired of that. It was like, oh dear God, another person who thought that the database should be handling 10,000 queries to render a single page. By the way, the biggest number that I've ever seen was 17,000 queries to render one page. That's 17,000. And it's like, yeah. And most of the time, it's not because you have a really complicated system or you have some crazy needs. It's because the data model is wrong or whatever. And eventually I started literally dreaming at night about finding a way to fix that. Now, my problem was that I was working with pretty smart people, and they were passionate and interested, and they were doing the right thing, but they kept falling into these huge pitfalls. Now, we're talking about 20 years ago. 20 years ago, you didn't really have the concept of pure front end. You had people who were, okay, I know more HTML than SQL, but that's about it. I mean, today we have people whose whole job is HTML, CSS, and responsive design, and that fills up full-time employment. And you have people who have no idea how to center a div, me among one of them. So
thank you for grid and flexbox. Just
yeah, you're using terms I'm not familiar with. But the problem thing was, okay, think about what it's like for someone who is a full stack developer and they have so many balls to keep in the air. You have to juggle so many things. Oh, I have to make sure that this works on Safari on iOS because on mobile. And I also have to make sure that Android devices from 5 years ago are still operational and what the hell is going on there. And alongside with everything that I still have to do, I also have to make sure that the backend works and can scale and all of those sort of things. And no one can do that. And what I wanted to do is at least let's fix the database area. Let's have something that wouldn't require so much attention. And it got so bad that I started waking up at night and having diagram and components of code running in my head, like the scene from Minority Report where you start moving things. I had that in my head
Yeah.
about how it should work. And what ended up happening was that at some point I said, okay, I'm sick of that. I would spend a weekend to pour it all out, write all of the code, and then will figure out how it's going. And then, it would be out. Turns out that it wasn't out, and I spent about 20 hours days for several months working on that. And at some point, I says, okay, I cannot sustain that. So either I have to quit doing that, and it wouldn't let me, or I have to try to make that into something that I sell so I can make a living out of that. And that was, dear God, 13, 14 years ago, almost 15 years now. And RavenDB has been a product for the past 12 or 13 years, been in production, deployed, and the two things that it does more than anything else is it is meant to allow you to build business applications easily and transparently. And more importantly, it aims to make it so you write the code, you generate your queries, and then RavenDB is going to figure everything else out for you. You don't need to spend 6 weeks before release trying to figure out how to modify your schema because someone needed another column or rerun a whole suite of performance tests to figure out what indexes you need when the system have more than 10 users at a time. So that's the background. That's how I got to where we are today.
Oh, that's crazy. And so your primary background, when you say you don't know how to center a div, it's mostly on the back end languages, right?
Yeah, so I mostly write in C# and other backend systems. My private background was what you would call today a backend developer. At that time, so it was you build a web application, so you do the HTML and the C# or whatever, and the database schema, everything in one go. But absolutely, for the past 12 years, basically, I've been working on database engines more than 18 months.
Cool. No, it's really amazing. It's a good story to always hear, like kind of why something like this started. And I feel like every time I've talked with like a founder or a CEO or whomever might be starting a project, they are always it's always from a need of some kind that they had this idea and then they like kept building on it. And some of them just kind of are a flash in the pan and they have to go away, or it's like an OSS project and they just can't maintain it outside of like having a regular job and family and everything else. And so it's amazing when you hear a story like yours that you're able to continue with that and build it into a full-blown business and keep things running.
I
So,
I have to tell you, I sat down with myself and I had a napkin and I wrote down a business plan. And the business plan was uh, not in case I would succeed because that was not possible. My business plan was okay. This is how much I'm willing to chase this goose at this point, which was just before I would lose this shirt and house and everything that I have.
yep.
Then this is when I'm pulling the plug. I try, I fail, we move on. And the surprising thing about it is that I kept not hitting those milestones. And that's basically how it rolled. It started and then it picked up, and suddenly we needed more people to handle the load of requests, and users and customers actually came, and that was pretty gratifying and completely by accident.
That's amazing. That's really cool. I love it. I love happy accidents. Let's say that.
That's for sure. Yeah.
Cool. Okay, so what we are going to do now is jump into an advertisement for our sponsorship. But then when we come back, we're gonna check out RavenDB and see what it's all about, right?
Okay. Yeah.
We'll be right back.
How in the world could I forget about this?
There's no need to freak out. We have Storyblok.
Robert, you're right.
But we still need a plan.
Okay, how much time do we have left until the launch?
24 hours.
Okay, let's go.
We are ready to publish.
So let's get this baby online.
Thank you once again, Storyblok, for sponsoring us. Really appreciate it. Okay, Oren, you kind of told us your background, your history. Let's dive into RavenDB. I believe I kind of threw this at you last minute, but you have an example that we can walk through, right?
Sorry, I have a what?
An example for us to check out RavenDB, a little demo.
Yeah. So let me share my screen, and you should be seeing it now.
Awesome.
And what you're seeing here is RavenDB on the cloud, and you can run RavenDB either as a Docker, Kubernetes, whatever, on your own systems, or you can run it as software as a service. What I wanted to show right now is we're going to actually go into this instance. And let's start by talking about what RavenDB actually is. RavenDB is a document database. And what this means is that this is a database that allows you to store JSON documents. And one of the things that I realized when we're building business applications, a relational database makes very little sense because it forces you to break down your data model into individual rows and columns. But modern applications have so much data that even a shopping cart would be 15 or 20 tables. And now I want to render that shopping cart. It is incredibly complicated to stitch together the data from all of these disparate tables. So the whole idea is that I want to have a database that works as my application does. So if you go into RavenDB, this is the management studio. You just goes in and start working. I don't know if you noticed, but I was actually using certificate authentication, so everything is secure and encrypted and stuff like that.
Yeah, that's amazing.
What I'm going to do, I'm going to define a database, and we're going to set a replication factor of 3. I'm skipping that factor for now. And we have a database, and I can put some documents here. It's more interesting if I work with actual demo, with actual data. So I'm going to create some sample data. And the basic idea now is that now we have collections. And if you're using something, other databases, a collection is very similar to a table or collection in MongoDB or something like that. And here is an example of some data. And we go in, and now you can see that a document is just a JSON document. And that's the whole magic, basically. Because now I'm able to work with the data in the same way that I'm working at in the front end. Because practically speaking, modern applications talk between front end and back end using JSON, a JSON RPC of some kind, gRPC, whatever. So you're sending JSON documents around. And you want to have that same model all the way to the back end. But where is it starting to get problematic? When you actually start needing to, okay, here is a slightly complex object. Here I can see that I have an array. Here is another array, those sort of things. If I was trying to model that using a relational database, then, this would sit on many different tables. Let's look at slightly more complicated system. By the way, the data model that we have here is basically your standard online shop. And you can see here is line items. And here is, again, more complicated objects. So far what I'm showing you is syntax highlighting for JSON. It's really not that impressive. It's getting impressive when you start to realize that now you have something that is actionable. So let's go here and ask for employees. And I'm getting some results back.
Oh, nice.
Yeah. So a few things that are important. First of all, I don't believe that there is anyone who is even have slightly familiarity with programming who is unable to exactly understand what's going on here. If you compare that to the way MongoDB does things, which you basically build a really complicated JSON expression, this is clear and obvious. For that matter, I'm going to ask a more interesting question. And I'm going to do some groupBys. What's your problem? Oh yes, because this should be on where. Sorry. Yes. So here are the number of employees that they have in London.
Nice.
And I don't actually need to really think about it, especially if you have any background in databases at all. And that's really important because one of the key issues that you're facing, especially if you're not, spending 20 years building backend systems, is that you need to deliver an application. And the database is one component out of that, and you want it to be transparent. You want it to be something that you just use and it does the right thing. You mentioned Flexbox and another thing to center a div earlier. A large part of that, if you have to do things manually, it takes so much time. And if you have the right tooling, then everything works. And suddenly your velocity of delivering feature is so much higher. So we have this, and it makes things easier. But before I dig in deeper, I want to go here and look at employees. And here is Michael. And Michael is interesting because this is JSON documents, but I don't deal just with JSON documents. In application, I have to deal with so much other details. So for example, I may have an employee photo, and this is an attachment on a document, just like you have an attachment on email. So the model makes sense. And if you're building a list management system, you can store here the photos of the two in the list and the signature and all sorts of stuff like that. If you're building an IoT system, RavenDB has the capability to store time series where you track data modification over time. And now we can run queries and aggregation over those sort of things. Now, what I'm showing you right now, this is the user interface. This is how developers work with the system when they are developing that. This is an example of how you work with the system from code. So RavenDB is a backend database. You would typically use it from your backend systems, and you write something like this. So I create an object, store some details, call store, and eventually I'm committing all of those changes to the database. If I want to make a query, let's do an interesting query. So you can see how it looks like. And we have clients for pretty much everywhere that you want, but this is a simple demo. So give me all of the employees where the first name is Anne.
Nice.
And it's clear and it's obvious and you don't need to really think about it. Now, but let's talk about this query for a second. What's the problem with something like this? I'm going to run this query. For employees where first name equal Anne. And I get the result. And that's nice. It's happened quickly. What happened if, but how many employees do I have? I have 9. That's nothing. What happened, and as the size of the data grows, what would happen? The system would start to slow down. Now, as a developer, when building the system, I'm not going to see that. I'm working on powerful machines, I'm working on a small data set, and there is one user. So there is a pitfall that is going to tell you, hey, there is a problem. But let's look at what actually happens when RavenDB does that. So what I'm going to do, I'm going to delete all of the indexes in the system and rerun this query. And we can see that we get the result. What you will also see is that there is an index here for you. And as you can infer from the name, this is an automatically created index. So what happens here this is the best example I have to show a pattern of ownership of decisions. So what I'm going to do at each and every point in time, I'm going to make it so you don't have to make a decision. RavenDB is going to make it happen for you. So we send a query to the database. There is no index for that. So we have to start doing a full scan of the results. If I'm already going to scan of the result, I might as well create an index for that. Your next query is going to be a lot faster. Now, let's make another query.
You don't have to manually create that at all. It's dynamically generating.
Correct.
Wow.
Now,
Okay.
now I'm making another query. And again, this is the first time RavenDB solves this query. I have two indexes by first name and last name. Now, in a few seconds, something really interesting is going to happen. And that something is that RavenDB is going to say, hey, you know what? I don't need that index. That all index just by the first name, anything that it can do, this index can do as well. So I can remove that. So now what happens is that you have the ability to automatically and transparently get the right set of indexes based on your actual load. One of the things that is really frightening for many people is that, okay, I'm making changes to my application. Did I change the way the query behaved? Now I'm going to suffer a slowdown in how the system behaves, and that is an insane amount of time to sit and ponder and fix, and then you have to do all sorts of really crazy trade-offs. Do I want to make write faster? Do I want to make read faster? And RavenDB just takes all of that away because we are making that simple and easy. For that matter, let's look at this employee. And you can see that Anne is fluent in French. I want to do a search on this. I want to see who else is familiar with French. So what I'm going to do, I'm going to ask RavenDB to do that. And it gives me a list of users. And if we're going to look at Michael, I'm going to assume that this is correct, but there's a whole bunch. Okay, here is French. There's a whole bunch of details here. And again, what just happened? What just happened that did something that seems really obvious. But if you do something like that in a traditional database, in Mongo, Firebase, SQL Server, MySQL, stuff like that, this is now either you're going to do a full ON scan of the data, or you have to define full text search indexes, you have to define a whole bunch of details. Or what you would typically do is, I'm going to have to integrate Elasticsearch into this in order to get good search results, which is utterly insane. I wanted to have a box that says search, and my users want me. My competition for this is Google, because they do search very well, and this is what everyone thinks that they have to do. But I don't have the Google budget for that. Yeah. So here's an example. Okay, I found something with French, but I can't show this to the user. But I can ask nicely, hey, tell me how this works. And now RavenDB will actually go ahead and tell me. Here, and now you can do the pop-up with the yellow lights on everything, or all of the URL that you want to manage that. So instead of me having to manually figure those sort of things out, it just happens. And we can go here. By the way, notice that now we have an index, a new index, by first and last name, and we now allow full text searching on the notes field. We do highlighting on that. Everything is done for you. Now, let's see slightly different semantics. What I'm going to do now, I'm going to look at orders. And now you can see, okay, here is orders. And I see that it is changing over time. So let's add a new item. And wrote it. I made a modification to the data. And now I can see here, not this one, hopefully this one, yes. So now you can see here something really interesting. I defined orders to have revisions. So now I can go back in time and see how it happens.
That's cool.
So now I have audit trail. Now I have the ability to diff my data if necessary, stuff like that. Here is another thing that is really cool. I want now to be able to search for all of the orders that has product 11. And that looks kind of hard because now I have to do some nested query or something like that. So I'm going to do this. If it goes ahead and find it for me. Now, and again, now I have the right index, and the index is important because as the size of the data grows, I want the latency for the latency of my queries to remain consistent. So we can see here that this takes about 0 millisecond to 1. But again, we have almost no data. 830 orders. So what I'm going to do now, I'm going to run an update operation. And I'm going to increase the number of documents that I have for orders by a factor of 100. So this basically says is for each one of the orders, I want you to execute this JavaScript code. And I want you to, this is the document ID, and slash in the end means that figure it out and copy this document. And you can see how it looks here. So now we have a whole bunch of these here. And in a few seconds, we increase the size of the data by 100. And you know what? I still don't like it. I don't think this is enough. So let's make more of that. And while this is running, let's inspect how the system behaves. You can see, okay, let's throw hundreds, thousands of writes per second into the system and see how it works. It worked quite nice, even if I say so myself. And now that we are talking about a system that has 200,000 items, let's go ahead and rerun the query. You can see that, okay, now it takes 20 milliseconds, but it takes 20 milliseconds while I'm still doing a whole bunch of queries. So that's not a nice place to be in. Let's run it again. By the way, the latency here is because I'm in Israel and this server is in Frankfurt. So there's some network latency between us. Sure. This number is what you're actually seeing on the time that it takes to process the query on the server side. Again, and by the way, this is another, I don't know if you noticed, but you can see that even though the number of results that we have keeps growing, and even though the size of the data that we have is now going to exceed 500,000 in a few seconds, the key issue here is that we are still able to get results in a consistent time frame. And the more that I query, the faster things are going to become. In a similar fashion to how RavenDB creates an index for you on the fly, RavenDB is also going to notice what areas in the system you're going to operate on, and it's going to optimize that in slightly more complex way. Keep it in memory, generate more things as we go, etc. Now, let's break this. And now we have just under 700,000, 700, just under 700,000 documents. Queries keeps being really, really fast. And this is important. I don't need to worry about it. RavenDB would fix it for me. But for that matter, let's talk about something else. Now I'm going to issue a query that's going to ask me to summarize things by companies. So already saw a little bit of queries by using a groupBy. Now I'm going to do that on a large set of data. So number of orders per company. Now we have 700,000 documents. And it's going to take a little while to run this. And while this is running, we can monitor and see what's happening. By the way, oh, it's done. Okay, so here are some of the results. It is still, by the way, processing that. So a key aspect, and it's done. A key aspect of the way that RavenDB manage things is that we want to keep your system up and running. Instead of getting you stuck with, oh, here is a query that's going to take 2 hours, we will give you the results as soon as possible. For that matter, let's rerun this query. And that's weird, because previously it took me 15 seconds to run this query, but now it takes me 2 milliseconds. Oh, it's probably cached. Let's do something else. Count as on desk. So give me, and that's fast. How does this work? Because now I'm doing aggregation over 700,000 documents, and the reply is instantaneous. What happens is that, like all things, RavenDB actually generates an index for that. So as a general rule of thumb, RavenDB doesn't take a lot of time to query, because the course has been shifted to the indexing stage. And so by the time that you query, you already pay that cost. In almost all systems, the rate of writes to reads is ridiculous. You're reading 1,000 times more than 1,000 times for every write that you have. So what RavenDB actually did, it went ahead and computed disaggregation based on the company name and gave me the result. And now it is able to give me the results instantly. But what happened if what I wanted to do was something that is more complex? For example, right now I can see that we have these tea time chocolate biscuits and a lager, and they were purchased together. And what I want to see for each company which products were bought and how many I purchased per company. So this is somewhat complicated to express. So what I want to see is for company 67, I want to show that they purchased 15 of tea time and 12 lager, but not for this particular order, across all orders that we have. Try to imagine how you can express something like that as a query, and you realize that this is really awkward. So the way that RavenDB does that is to allow you product sales by company. To allow you to do that using an index that you define in your own.
Ah, okay.
So what I'm going to do now, I'm going to define the following.
So would there be a way to build this like call in JavaScript and it auto do this? Or is this just like so complex it doesn't make sense?
Let's see if I have this.
I'm really stuck on the fact like every other thing I use, like Firestore or anything, I have to like create all of these indexes. I'm kind of blown away by this.
Go ahead and do this. And you can see here, think about what we have here.
Mhm.
Here you have a TypeScript system where you define, using strongly type the definition of your system.
Gotcha. Yep.
And notice that we are doing some relatively simple computation here. And then we are able to query over that. And we can do, here is a more complicated example. Well, in this case, it's not really that interesting. This is a count of employee per query. I could do that as a simple query as we saw previously. But the idea here is that what I'm writing here, you can write in your code. And the reason this matters is that think about what it means in terms of how you do data migration. How do you, hey, I need to go back to the version of the database that I had in the production branch to test something out. You can switch to that branch, run it, and it uses this. So the whole idea is that you define all of those elements inside your code in the same version control. Migration is a breeze because of that, and all of those sort of things. And I want to show you the idea here. So what I'm saying is company or dot company. And what I want to do now, I want to say products and map quantity L dot quantity and product L dot product. And if you think about what we actually do here, let's go and look up. So what I'm saying is I want to get this field and this field from the lines. So the output of this is going to be basically this would be more or less the output of the map. And now what I'm going to do, and by the way, I never bother to remember how to do those sort of things, so we have cheat sheets all across the board. I'm going to do this. Goodbye, company. And
It's
here
really
we have,
nice. I like that.
so what we have here, we have products. And the nice thing about this is that now I have to take a list of those and a list of those and generate them together. So what I'm going to do, I'm going to say, okay, we have, and I can remember the syntax. So we have the accumulator and the current value. And the current value is an array of those. And I want to group them together based on the items. And I cannot remember how to do that in JavaScript off the top of my head. I'm going to write it instead using C#. Excuse me for doing that. I did spend 20 years working on C#, so I'm more familiar with this. So o.company, products equal o.lines. It should be very similar, but I can't remember the other syntax. Product, text.quantity. Yeah, it would help if I could spell. Okay. Now here from our in results, group company, G. Now what I have is company is what we are grouping by, and products is select many. Now flat map, that was what I was missing previously. Never mind. X dot product. New. P dot key and sum. So lots of magic incantations, and what's the problem? I have company, let's see. Yes, because I have a typo. So why should I allow it to have a typo? Yes, because I'm using the wrong thing. Thank you. Now it's working. And now what we have, it's going to start doing that. Couple of things about this. If you're familiar with databases, then one of the things that happen when you start indexing things is that the system basically hangs because it locks the table and stuff like that. In this case, I can go here and let's update the table and say this is now 135, and it works while this is running. And I'm able to query that while the system is still working. And now we get to see something really interesting. So here's the result. And apparently for company 32, and you know what? It's nice that I have these results. It's not really that interesting because what the hell is this? So let's do this.
This is really cool. I mean, just having messed around with Supabase, they do a lot of the same, but it's Postgres underneath. So you actually have a complete self-created database on top of all this.
Correct. So what I'm going to do now, I'm going to say, hey, I'm following the association. So now I have name as load p.product and quantity p.quantity. And here. Yeah, sorry. And now this just happens. So RavenDB is a non-relational database, but you're able to do those sort of things directly natively. You're also able to run any sort of code that you want. For example, I could do lowercase, bring stuff from other places, traverse the entire graph, and all sorts of things directly and transparently. And that means that for many reasons, you no longer have to struggle with the modeling. Because think about it, I have a document model and I can flow out from that without having to pay the cost of doing joins or Cartesian product or something like that. There's also another really cool feature that I like. Let's look at something like this. For models where ship to city is London. And it's going to run a while, it's going to index, and then it's going to give me some results. The key thing about it, I want to show it to you. I want to show the orders for London as a user, to the user. And when I need to do that, I'm going to see all of those, and I have no idea what this means. So I'm going to be able to do something like this. Let's say o.freight, but now I want to do all of employee. And e.name. Again, I have it in this manner. But before I do that, now I need to also, I want to render that, I want to apply some logic on all of those companies. Now, here's what you would typically do. You would run, let's do a query to get these results. And then start loading any one of those one by one. And what's going to happen is that this is going to say, okay, database query, database query, database query, database query, database query, database query, etc. Sometimes like, this and this are the same. This employee one, I can skip that. But you still have tremendous number of database queries. And because the database is fast, you're paying most of the cost in latency. In the front end, you're used to being aware of that because you know that you have to pack your resources to avoid additional remote calls. It's the same thing from your back into the database. It's also a remote call. So you can do this. And notice what happened. We made one request to the database. And here are all of the companies that belong to the same, to the results in the query. Same thing for the employees. And the nice thing about this is that this is a single query that you have to run. That's it. In terms of the API, we have something about here. Here we go. So you can see that I'm saying, hey, I want you to include this related product. And here you can see that I'm loading inside nested for loop. But this is going to be really cheap because I already have that in the session. So 0 remote calls all around. Now, here's another factor. I'm actually running in a distributed system. We just haven't seen that before. I have to authenticate. So now we reload, and here's what happens. What happens if one of my server goes down? I'm going to go here and do something nasty. I'm going to force the restart of a node. And while this is happening, let's go and add some data. So let's see what's happening now. We have a partial failure mode. And go away. Now we are node B. And you can see that partial failure mode or not, I'm still operational. I'm keep accepting writes, I can do queries, everything keeps on working. And the whole idea here as well, by the way, now it's up and back again, everyone is happy. But the whole idea with this is that I'm writing my code and I had a failure. This piece of code is going to handle that. I don't need to put a try catch here because this is handled internally. We're going to do the failover and all of those sort of things for it. We are also able to do more interesting things. For example, let's kill this. Let's look at this. What is it saying right here? I'm putting quite a bit of load on the system because I'm writing hundreds of thousands of documents. And it told me that I had a slow write to disk. Well, obviously I did. I chose a standard storage type. And I hammered that, so I started to get in slow results. But you know what the fun part of that was? No, that's a different one. When I had a problem and we didn't notice that, and we probably wouldn't notice that, but RavenDB is being proactive about those sort of queries. For that matter, let's go here, and I'm going to issue an expensive query. So this is a query that gives me 20,000 results. I'm going to do this, and I'm going to do this thing. I'm going to remove the page size. This is going to run, this is going to download. And it already finished this query, probably, because it just need to stream that. But in a few seconds, I'm going to be able to see, here it is, tell me that is a problem. In a few seconds, it's going to tell me that, hey, I had a query that took a lot of time to process. And if I have a slow IO, it's going to tell me about that. So the whole thing is really designed to the point where I don't need to, I'm now actually worried that it would try to parse all of that because I have JSON. I would skip that. So the whole thing is about making it so as a user, as a developer that is using RavenDB, I don't need to think about how this works or why it is working.
Yeah, that's great.
Because the database is managing that for me. Now, there is a ton of additional features that you have. Including a whole bunch of ways to push data from one location to the next, working with distributed system and other stuff like that. I want to touch on one last thing, and that thing is when we are talking about building complex applications. And one of the things that we have to deal with a lot is how do I handle background tasks? So whenever there is a new order in the system, I need to run some processes on that. So I'm going to write the following code. And here all of the employees in London. And this is, I've shown you how this works before. But now something really interesting happens. And now I have this guy, a subscription. And this is the way for you to subscribe to a query. So RavenDB is going to send you the result of this query. You're going to process that in batches. And when you're done, you're not going to close the system. No, you're going to keep on listening. And whenever there is a new document, whenever there is something that matches a query, RavenDB is going to call you about that. And then you can process that, which opens up a whole new world of possibilities in how you're managing this. And last thing that I love to do, because I love abusing the system, look here. Here we have a cluster of 3 nodes, and they are tasks. And I'm currently subscribed to this task, and I'm starting to process that. And now I'm going to abuse the system again, and let's restart node B. In a few seconds, we're going to see that the cluster is going to detect that the node is down. It's down now. And notice what happened. We redistributed the ownership of tasks in the cluster. My code that is processing against this is just going to keep on running and just going to not notice something happen. I may have 1 or 2 requests that would have slightly higher latency when we discover and operate on that, but that's about it. And behind the scenes, when this node comes back up, we're going to fill it up with everything that it missed and then reassign off those tasks for you. And those are the sort of features that you see in other locations as well. And you can see that the entire process took under a minute. But the whole idea here is that the point of RavenDB in this scenario is that I don't need to think about it. Everything is being managed for me. If you want to go deeper, there is a whole wealth of information that you can dig into and see when everything that you want, and there's more beside. But the whole idea is that I don't need to.
Yep.
And one of the things that happen is that we get users who come to say, hey, we forgot that it is running. For 7 years, I have a customer tell, hey, I did not know that we had it in our architectural in the architectural diagrams, because we did multiple hands-off over the years, 7 years, and it never came up because it never was a problem. And that's
really good.
Yeah, and going back to my initial discussion, why we beat RavenDB, I think that for the most part we did a really good job achieving to the maximum extent possible that you can actually get to this. You build an application and you use a database because you have to store data somewhere, but you don't actually have to worry about or think about it.
Yeah.
It just works.
That's awesome, and thank you so much for the demo. I do want to share just really quickly the main screen here. So I just want to show off, it's ravendb.net. That's probably where you can find all of the information that you might need. The cool part, once you're out here, you can check out the different products that are set up too. So they do have their downloads. So your downloads are out here that you can run it out of. I love that there's like a Docker instance, since I'm used to running app right out of Docker these days as well as the cloud hosted solution. So I would imagine zero downtime on the cloud hosting. Is that how that works?
Correct. Yes.
Perfect.
Yeah. And if you, by the way, when I was running, when I was doing it, I explicitly introduced errors into the system.
Yeah.
And think about it. The reason we do that is literally so I can demo to you how here's the system running. I'm going to do an error and something happens. And a couple of things here. We have a free tier, so you can start using us completely and free with no commitment. And there is also, if you go to RavenDB.net in the product sections, there is a Playground Studio.
Oh yes, I did see that. Let me go
Yeah.
back there. Um,
So it's the second thing. And if you click here, this takes you to a live a public instance
that's
that you can,
crazy. That's
yeah,
really neat.
yeah.
I love that.
So just point the browser to that. There is nothing that you need to do, not even nothing. It just works, and you can
Very
start
cool.
playing with it. Yeah.
Awesome. Thank you for showing it off. We're gonna kind of switch gears, and hopefully, I gave you enough time. I'll give you a few more minutes to think here, Oren. But we're gonna jump into our Purrfect picks. Without Brittany here, I only have one pick that I have right now. So let me switch views just real quick. It's a little hard to see. This is called Mesher, and I'm like constantly playing around with like background, like linear and like all of the different ways you can represent this. So if you go through random, you can set all of these different colors that you want, all using HSLA. You can kind of flip these to wherever you would like them, and at the end of it, you can actually click export and grab it out for your CSS. So I really enjoy this. It's on csshero.org/mesher. So check that out for sure. Oren, did you come up with a perfect pick?
I did, but it's going to be as far away from the typical scenario that I think you have as possible. So you were talking about generating CSS and beautiful things. I'm going to take you all the way down to bits and bytes. There is a new programming language. It's like 5 years, so it's still very new programming
Yeah.
language. It's called Zig. It is an unmanaged language, and its purpose is to replace the C language. So it's aimed to be a better C. And
This one right.
mhm. And when I'm looking into that, and I looking into building the high performance system, high reliability, those sort of things, this is a language that is a pleasure to use. And for the most part, it gets things right.
Wow, that's very cool.
Yeah. So especially you can see here the comp time absolutely blew my mind when I saw how it works. It's a really fun thing to play with and work with.
So someone that might be familiar with like C or C++ could jump into this, or maybe even
Yes,
Python by the looks of it.
my expectation is that if you have even a few years, like a year or two of programming in any language, you should be able to pick it up very quickly. There are some very advanced features, but the core language is very simple and obvious, and it has a very rich system.
Wow.
I'm, yeah, I'm actually thinking that this is sitting on top of a LLVM and the compile infrastructure, so it produces production quality code, and you can debug that using VS Code and syntax highlighting, language server intelligence, the whole thing. It's really amazing to see how it works.
Yeah, that's incredible. Good pick. I'll add it to our list. Awesome. Well, Oren, thank you so much for spending some time with me today and breaking down RavenDB. Incredible story, kind of getting it started and where you're at today. It's unbelievable. I meant to ask you, like, is there VC funding? Like, what does the actual organization look like?
The whole point of RavenDB was that I wanted to build something that solved the problem. And one of the things that I don't like is if you take outside funding, you also take outside interests.
Very cool.
And I have the desire to build the perfect product, and we spent so much time getting the details right. And all of the RavenDB is bootstrapped, and that means that the core principles of deliver a really good product on time and making sure that at a reasonable time frame you shut down the computer and you go home and you can get rest. I had just one point I had to tell one of my developers, if you keep on staying in the office any longer, I'm going to charge you rent. And yeah, so the ability to deliver all of that and not have to worry about, okay, what am I going to say to the board about my next meeting? So Bootstrap made it possible and give us the ability to do things in a much more robust fashion, I think.